Good afternoon, everybody. I am Dr. A. Subbarao, Associate Professor in the Department of AC SR Engineering College. Today I am going to talk about the zener diode and its applications. Our presentation is like this. First I will talk about introduction and what is the need for zener diode, later working principle, and finally I will talk about the different applications of zener diode. Okay. So let us see what is the need for zener diode. Whenever we want to convert AC voltage into DC voltage, one of the important component required is zener diode. So the process of converting AC to DC is called as rectification. In rectification process, one of the important component used is zener diode. And the zener diode can also be used in our cell charger circuits where AC voltage is to be converted into DC voltage. So zener diode is an important component in rectification process. Next slide. Let us talk about introduction to zener diode. Zener diode is like a normal PN junction diode, but it is heavily doped PN junction diode. Let us see first how a PN junction diode is formed. A PN junction diode is formed by combining P-type and N-type semiconductor. Then what is the need for PN N-type semiconductor? All of us know that a pure silicon cannot conduct much. When an external agent such as doping is added to a pure semiconductor, then its conductivity can increase. So a p-type semiconductor is formed by adding trivalent impurities to a pure semiconductor such as silicon. Similarly, an n-type semiconductor is obtained by adding pentavalent impurities to a pure silicon semiconductor, so that its conductivity can be increased. Now a PN junction diode is formed by adding p-type semiconductor and n-type semiconductor one after another using a special fabrication technique. And our zener diode is nothing but, it is also a PN junction diode, but it is a heavily doped PN junction diode. And it also allows flow of current from one direction only, that is from anode to cathode. So this is the symbol for zener diode, and these are the various specifications for zener diode. So its type is it is a passive device, and its working principle mainly lies in zener breakdown region, so on. And let us see mainly the working principle. Zener diode can be operated in forward bias and reverse bias. When positive terminal of battery is applied to anode and negative terminal of battery is applied to cathode, then zener diode is said to be in forward bias. In forward bias, zener acts like a normal PN junction diode. So it allows current to increase as voltage increases. So in case of PN junction diode, as voltage increases, current also increases. Here, likewise, in zener diode also, as voltage increases, current also increases in forward bias mode. And main application of zener diode lies in its reverse bias. In reverse bias, as voltage is increased up to the breakdown voltage, no current flows. Accordingly, the voltage across the diode is zero. When the voltage is increased up to the breakdown voltage, a phenomenon called zener breakdown occurs, and large current flows and voltage remains constant. And this procedure is useful in the conversion from AC to DC. Then what is zener breakdown? So when voltage is increased up to the reverse breakdown voltage in reverse bias PN junction diode, a high electric field is applied across the PN junction diode, and this high electric field breaks the covalent bonds and so many electrons are released. Due to movement of these electrons, large reverse current flows in case of zener diode, and this effect we call it as zener effect. Okay. So at zener breakdown voltage, large current flows and voltage remains constant. Wherever voltage is to be remain constant and large current is to be flown, at that cases we can use our zener diode. Next slide. So this is the characteristic just I talked about it. In case of forward bias zener diode, as voltage increases, current increases exponentially. So this is called forward bias wave characteristic curve. It is exactly similar to that of PN junction diode. So this is the main working principle of zener diode. As reverse voltage is increased up to the breakdown voltage, there will not be any current flow. Here you can see voltage is on x-axis, current is on y-axis. As reverse voltage is increased up to the breakdown voltage, no current flows. But when the voltage reaches up to the breakdown voltage, suddenly a large reverse current flows here due to zener breakdown. And beyond this also, if you go on increasing the applied voltage, the voltage across the zener diode is breakdown voltage only, but large current flows here. So this part of the curve is responsible for regulation process. Regulation is nothing but conversion of AC to DC. Now same thing I have mentioned here, and here I am going to talk about application of zener diode as a regulator. So zener diode can be used as a voltage regulator. To control the voltage, zener diode is used. So when the reverse voltage, when the input voltage here, let us see the circuit of zener diode. Zener diode is connected in reverse bias here. When the input voltage is below the breakdown voltage of zener diode, the output voltage produced is zero, because in such case the zener diode is said to be in forward bias and it acts like a short circuit. The output voltage is zero. When the input voltage is increased up to breakdown voltage, due to breakdown mechanism, large current flows and voltage remains constant. So the output voltage is equal to the breakdown voltage of the zener diode. In the third case, as the input voltage is increased beyond the breakdown voltage, then also the voltage maintained across zener diode is the breakdown voltage only. But a large reverse current flows. So this zener diode can be used as a voltage regulator. That is to control the voltage. To maintain a constant voltage, we can use a zener diode. So not only this one, in so many circuits where the AC voltage is to be converted into DC voltage, in such cases you can use zener diode. So here my question to the students is, can you tell some applications, some other applications where zener diode can be used as a regulator? What are the other breakdown mechanisms that are available in case of diodes? So these two questions we have answered. And thank you. So let us see the application of zener diode as voltage regulator. Before that, what is meant by voltage regulation? The process of converting AC to DC is called voltage regulation. So wherever you want to maintain a constant voltage, even though the supply current is varying, there we can use zener diode as a voltage regulator. And this process is possible when zener diode is reverse bias. When zener diode is said to be reverse bias, then a zener diode is said to be in reverse bias when positive terminal of battery is connected to the cathode of the zener diode and negative terminal of battery is connected to the anode of the zener diode. When zener diode is reverse biased and when supply voltage increases, the reverse current in zener diode is less. When reverse voltage is increased up to the breakdown voltage, then large current flows due to breakdown mechanism, zener breakdown mechanism. What is this zener breakdown mechanism? When the voltage is increased to zener breakdown voltage, a large electric field is applied across the zener diode, which breaks the covalent bond and makes the electrons freely available. Due to movement of these free electrons, large current flows. So when the voltage is increased up to the breakdown voltage, large current flows due to these free electrons and voltage across the diode is maintained constant. When the voltage is increased beyond the breakdown voltage, then also the voltage maintained across the zener diode is nothing but breakdown voltage. Hence from this we can know that when the voltage is increased beyond the zener breakdown also, a constant breakdown voltage is maintained across the zener diode. So that's why zener diode is used as a voltage regulator. Now where this voltage regulator is useful, let us see that. Voltage regulator is useful in the process of converting AC to DC. We already know three components are required to convert from AC to DC. First is the rectification, followed by the filter, and then regulator is used for this. Okay, in this one the first component is the rectifier. Rectifier is the process of converting to AC to pulsating DC. Next, filter is used. Filter takes this pulsating DC as input and it gives a better DC, and still it contains of ripples, and the regulator takes this ripples as input and it will give a better DC. So in this purpose, in this, the first component is rectifier. There zener diode can be used. So zener diode can be used as a better voltage regulator. That means a constant voltage is maintained across the zener diode even though supply voltage is